All right, IM2 classes. Today we're talking about angles and polygons. So things we need to talk about before we get into the angles. Um, so first, what we're talking about polygons. So polygons are just they're shapes, right? They have straight sides. We're gonna be dealing with convex polygons. So we're not gonna have any like um, sides that are coming in. The most common example of a concave polygon that we wouldn't see would be like a star, right? Sorry for my crappy drawing here, but that'd be a convex because it has sides coming in. Or excuse me, concave. We're not going to be dealing. We're all going to be dealing with convex here. Um, we'll have equilateral polygons. So equilateral means all the sides are the same. Equal angular means all the angles are the same, right? And then a regular polygon means sides and angles are the same. So that should be a little review from IM1. First thing we're doing, we're going to be talking about the sum of the interior angles, the angles on the inside of the polygon. So here, this is a hexagon. It has 6 sides. So 1, 2, 3, 4, 5, 6 angles as well. The sum of the interior angles of any polygon, we use this formula, n minus 2 times 180. And this is going to be an important one. In IM1, you really just need to remember the sum of the angles of a triangle, right? The sum of the angle of a triangle is a 180, right? Um, so for this one, it's just n minus 2, 180 for all of them. So if we did that for a triangle, 3 minus 2 is 1 times 180 is 180. So we're going to be doing problems like that you dealt with triangles, but on bigger polygons. Um, One thing you can do, I'll do this quickly. We'll talk about it more in class. But you can remember how that works. If you can remember, the interior angles of a triangle add up to 180. You can split any um, any polygon like this into a bunch of smaller triangles. Let me do that one again, right? So this 6-sided polygon, I can split into 1, 2, 3, 4 triangles. Each triangle has an interior angle sum of 180. So 4 times 180 is, what is that? It's not working right now. 4 times 180 is 720, right? So 6 minus 2 is 4 times 187. Anyway, we'll talk about more in class. Let me just get to some examples here. Before we do that, just prefixes. If you need to look this stuff up, this is on Google. I got this chart from Google. But yeah, you'll need to know these different prefixes. So coming in here, we're going to find the sum of the measures of the interior angles of this figure. First thing, let's count the number of sides. There's 1, 2, 3, 4, 5, 6, 7, 8. I'm going to use the formula that we just had, n minus 2 times 180. Right? The n is the number of sides, so I get 8 minus 2 times 180. 8 minus 2 is 6 times 180. 6 times 180 is 1080. Nice. And that's all there is to it. So the interior angles of this add up to 180. Right? On example 2, now we're trying to find the other thing. We're trying to find sides. So we know, if we read this, the sum of the measures of the interior angles adds up to 900. So if we do n minus 2 times 180, we know that is equal to 900. We are trying to find the number of sides, so we're trying to find n. So we set up this equation, and all we need to do is solve for n. So first thing I'm going to do is divide both sides by 180. So the times 180 divided by 180 cancel out. I'm going to bring down the n minus 2. Since I'm not multiplying anything by anymore, I can drop those parentheses. I don't need them there. 900 divided by 180 is 5. And then I'm going to add 2 to both sides. So, nope, wrong button. So the +2 -2 cancels out, and I get n is equal to 7. So on this one, our polygon has 7 sides. That's all there is to that one. Skipping ahead, we're going to find the unknown angle here. So first thing we need to do is figure out what all these angles add up to. So there's 4 angles here. So I'm going to do the n -2 times 180. It's 4 sides. So the n is 4. -2 times 180. 4 times -2 is 2. Times 180 is 360. So now that I know that, I can set this up into a little equation. I know that the sum of these 4 angles, so x plus 108 plus 121 plus 59, that all adds up to 360. And now I have a pretty easy equation to solve for here. So I'm going to add all those together. So 108 plus 121 plus 59 comes out to 288. So this is x plus 288 is equal to 360. I'm going to clean that up real quick. Ignore the others. Whoa. I got a lot of weird lines. All right, so it was 288 equal to 360. All right, and then from here, I'm just going to subtract 288 from both sides. So plus 288 minus 288 cancels out. I get x is equal to, that is 72. Done. So this angle in here is 72 degrees. So that's all you need to do for that. Figure out this how the measure of the angles, the interior angles, set an equation and solve that equation. So this one, I was going to skip it, but might as well go over this one. So again, first thing I need to do is figure out what these angles add up to. So n -2 times 180. There is 1, 2, 3, 4, 5 sides. So it's 5 -2 times 180. So 5 -2 is 3 times 180 is 540. These all add up to 540. So here's the thing. These little arcs in these angles here, that means they are congruent. These are congruent, so that means they're the same measure. So I'm going to call, that's not what I wanted. I'm going to call these M, just so when I'm writing the equation. And then this, the box, again, that means it's 90 degrees. A box in the corner means 90 degrees. So my equation, I'm going to write the m's first. So it's m plus m. Again, they're the same measure. That's what those arcs are telling us, that they have the same measure. Plus 90 plus 47 plus 119 is equal to 540. And now I need to solve this equation. So m plus m is 2m plus 90 plus 47 plus 119 is 256. Is equal to 540. Minus 256 from both sides. So that cancels out. I have 2m left over there. 540 minus 256 is 284. And then last step, divide both sides by 2. So m, in this case, is 142. 2's here cancel out. So that means x and y, since they're the same, are both 142 degrees. And then one more example, we're going to talk about the exterior angle theorem. It doesn't matter how many sides a polygon has, if it has 3 or if it has 100. The exterior angles are always going to add up to 360. And the exterior angles, how we define an exterior angles is that they are supplementary with the interior angles. Remember, supplementary means they add up to 180. So angle 2 and this angle in here, if we add them together, they'd add up to 180. They make a straight line put together. They'd be called a linear pair. You might remember that from IM1. The exterior angle is a linear pair with an interior angle. All right, we're not saying there's a bunch, we're not doing exterior angles out here and adding all of them. It's just one exterior angle per interior angle that you add together for this formula. All right, so the exterior angles, doesn't matter how many sides, they add up to 360, and it's only one exterior angle per interior angle that we add together. So here, real simple, we have a quadrilateral. We could figure out the sum of the interior angles does not matter, all right? Because since we're just doing the exterior angles, we know they add up to 360s. What the heck happened there? All right, so I'm going to add up all the angles. So it's 2x plus 67 plus 89 is equal to 360 because it's the exterior angle. And then you just solve this equation. So 2x plus x is 3x's, plus 67 plus 89 is 156. And then from here, just a simple two-step equation. I'm going to subtract 156 from both sides. Nope, wrong button. That cancels out. I get 3x is equal to 204. And then I'm going to divide. I'm going to divide both sides by 3. That cancels out. And get x is equal to 68, I believe. Let me double check that. 204 divided by 3 is 68. Yeah. So the x in that diagram is 68. And again, we go back and find the angles. That means this angle is 68 degrees. Great, 68 degrees. This angle would be 2 times 68, which would be 136 degrees. But we were just finding it out from there. And that will do it for us. More geometry next time.